Alright, so in the last video I talked about, towards the end, I talked about how we can concisely, very neatly organize our linear systems, and we'll go ahead and do that and introduce the method behind doing that in this video. So we have our linear system over here to the left. Alright, we have three linear equations, we have three variables, but we want to figure out a way that we can concisely organize this. Because right now it's a little jumbled. All right, so we can do this using a matrix, and there's really two kinds of matrices that we can use to make this happen. Let's go over the first one. So the first one is called a coefficient matrix. Coefficient matrix. And our coefficient matrix is pretty simple. And you know what? Let me go ahead and that might have been a little confusing. Let me go ahead and do this in purple because this will be a little better. Coefficient matrix. So all we're going to do, as the name might sound, is we're going to take the coefficients of each one of these variables, all right, in our equations, and we're going to put them into a matrix. And if you haven't seen a matrix before, they're pretty straightforward. They're pretty easy. So let's go ahead. Every single equation is going to correspond to the same line in our matrix. So we have our first equation. The first coefficient is 1 because we have 1x1. All right. Next we have a negative 2x2. And again, we're only putting the coefficients that are in front of each variable. Don't worry about writing the variable themselves. Next we have no x1 in our second equation, and that's because we just have a 0 coefficient. I spoke to that a little bit in one of the beginning videos. If you don't see anything, any variable in one of your equations in your total system, that just means there's a 0 coefficient in front of it. Next we have 2x2, and we have negative 8x3. Lastly, we have negative 4x1 and 5x2 and 9x3. Now, we'll go ahead and close this off, and this is our coefficient matrix. Again, it's very straightforward, very easy to visualize. It's just taking all your coefficients and putting them in a nice, neat manner. But there is another kind of matrix that we also want to use in linear algebra, and this one is used a lot, and it's called our augmented matrix. And our augmented matrix is simply our coefficient matrix augmented with the right side of our equations. And I'll show you what that looks like. So we're going to remove that bar, all right? And what we'll go ahead and do, sometimes you can write this line through it. That's helpful to let people know or let yourself know that this is in fact a augmented matrix. But what you're literally going to do is just the way that we wrote out the coefficients, you're going to write out the right hand side. So we're going to have a 0, we're going to have an 8, and we're going to have a negative 9. All right, and we'll go ahead, close this off now. So on this side, we have our coefficients. Again, it's the same thing as our left-hand side, and on this side, we just have our right-hand side. All right, it's very straightforward, really easy to think about, really easy to visualize. One thing I do want to talk about really quickly, and let me go ahead and just kind of grab this guy again, see if I can get all of it. Looks like I got it. And it didn't work, of course. But one thing I do want to talk about is what are we looking at? What does this even represent, right? It's important to be able to understand what you're looking at in math. I think most of the time, the hardest part is just getting through the notation. It's getting through what does all of this stuff mean. So if we're looking at our matrix and the left side of this matrix, or what is essentially just our coefficients, each column represents one variable. And this I will go ahead and do in our other color as well, just to keep things nice and neat and organized color-wise. That's x2 and x3. All right. And each one of these on the horizontal side represents the overall equation, right? So this right here corresponds to that right there. All right, and all of our x3s in all of our equations correspond to all of these right there. Okay, so again, your variables are visualized vertically as the columns of our matrix, and the equations themselves in our linear system are visualized horizontally as the rows, and they're visualized by their coefficients. And again, on our right-hand side, we just have each one of these right-hand sides, what the value that it's equal to, the constants on the right, in our augmented matrix form. Now we'll get into why matrices are important and how we think about them in later videos, but one thing that we want to also kind of stress on right now is dimension or size of our matrix. So the size of our matrix is the way that we kind of think about our size, right, is going to be the number of rows by the number of columns. Now, the convention in linear algebra, at least in our book, is that we're gonna denote the number of rows by m, and we're gonna denote the number of rows by n, right? And we could kind of see in the past videos, if you go back and look, whenever I was generalizing things, I would always go from, x1 to x2 to xn, right? And I would do even the solution set. Remember when I wrote those S's in red, it was S1, S2, some ellipses to Sn. And that should make sense because we're going to have n number of variables in our equation. And we're going to have m, so n number of variables. And we're going to have m number of equations in our system. So that's a very important distinction. You want to be able to understand that. It's pretty straightforward, but definitely remember that it's always thinking of the matrix as an m by n. Now m and n can be equal, in which case you just use 1. Typically the convention, so when m equals n, we now have a square matrix, so it's called a square matrix. Don't really worry about this right now, but the convention is to just use n by n. And again, that's not very important to worry about. It's just something that we'll see in later videos. But most importantly, just think about the differences between our coefficient matrix right here and our augmented matrix. And our augmented matrix is literally our coefficient matrix augmented with the right-hand side of the equations of our linear system over here.